each gantry, there are 3 gantries on this cell, and each one is passing the part to each other, so all the time the machine is on the move, but the spindles are always cutting.
Wow, we've got a machine that looks like 2 machines kind of stitched together, Dave, but there's 3 spindles all in a tiny space. What's happening here, David, on this Muratec machine?
Yeah, this is a project that we've got going on for a customer of ours at the moment that's got 3 operations to the component. So obviously starts on the left-hand side, there are turnover units and spindle 1, spindle 2, shuffle units, so we can produce 3 ops in one go.
Yeah, and we're going to talk about the configuration of this and how it's almost like a really tightly packed production line, but these are CNC machines from Muratec. What is it about the Murata machine that allows it to be producing parts in such a small space?
Well, they're very compact. The parallel spindle gives you a different option, really. If you're doing opposing spindle, then you have that transfer time, but with a parallel spindle, everything's always on the move, like the transfers, the turnaround, the shuffling, it's always happening while you're still machining.
And these are quite interesting machines in terms of this overhead arm that's doing all the moving of components around. What else is the benefit of having this overhead gantry system versus passing between spindles or having just a bar feeder and a parts catcher?
Well, like I said, each gantry, there are 3 gantries on this cell, and each one is passing the part to each other, so all the time the machine is on the move, but the spindles are always cutting.
Yeah, okay, fair enough. And I guess the benefit of this is, with a bar feeder, you're limited to loading in the raw bar stock. What happens with the kinds of parts you can put in this case, on the left-hand side at the start of the process?
Well, the left-hand side is a stocker area. That's where all the raw material goes. This component's got 3 operations, like I said. So it enables us to pick up with one gantry and pass it to the next, load the spindle. That's turning already, so that's already machining. Then it will go and get another one, and as soon as that finishes, it swaps, puts another one in, and moves on to the next. So you kind of fill it from one end and exit out the other end. So it's not 1 in, 1 out. It's 3 in and 3 out, and then it's constantly moving along the cell.
Yeah, so you almost turn machining into a continuous process. Correct. And what the customer here is quite a secretive customer. We can't really talk much about the exact application, but what would the customer like that's going to be using a machine like this? What's the kind of benefits for them to basically buy a machine that's got two machines, 2 spindles and 1 spindle, and put that all together? What's the benefits for the customer?
The customer, he's already got machines which are 1 spindle, 1 turret, and he's turning these components manually. So what we've given him there, we've taken his longest cycle time of the 3 operations, that's called them 2 minutes apiece. So every 2 minutes, this machine will kick out a part.
Yeah, and what do you think that means in the current climate of needing to try and maintain margins whilst reducing cost per part, for example? How does that help customers nowadays here in the UK who want to make parts, I guess, better, cheaper, and with the same accuracy?
That's correct. So, I mean, everyone's looking for cost per part. They've got to bring that cost down. You know, the world's not in a great place at the moment. So by replacing 2 or 3 of his machines with a cell like this, he can run unmanned, he can fill it up at night and come and empty it in the morning.
Yeah, I guess it's a joy if you've got a lot of these components to make. Then you can get one of these machines to keep passing them from process to process. What is it about the Muratec machines from Murata that allow them to offer this kind of solution?
Well, Murata historically were automotive. So this is automotive machining. You have parallel spindles and you can break the operations down. If you had another 3 or 4 spindles stuck on the end, then you can break that cycle time down even further and give even more cost down. So this is how you get a 5-minute automotive part and break it down into 30 seconds.
And we're talking complex parts as well.
Oh, absolutely, yeah.
Think of automotive, you're thinking of cast components that got lots of different operations, lots of milling, lots of turning as well.
Well, what they could do, see, op 10 could be the rough turn, second spindle's the finish turn, the 3rd spindle's the drill, the 4th spindle's the bore. So whatever the longest operation is out of those 4, that's tack time.
Thanks, Dave. So those complex components made with super fast cycle times whilst maintaining accuracy on these fascinating Muratec machines. They put 2 machines into one here, Matsuura showroom.